Hi students, welcome to lesson number 36, Measures of Dispersion and Overview. In the previous lesson, we have discussed about mean, median and mode. In this lesson, we will discuss about measures of dispersion. Introduction. The measures of central tendency, which mean mean, median and mode, give us one single figure that represents the entire data. Although measures of central tendency can be very useful, they tell only one part of the story. The measures of central tendency are not adequate to describe the data. Two sets of data may have the same mean, but they can be entirely different and there can be wide disparities in the formation of the distribution. So, in order to describe the data, we need to describe the variability or dispersion. In other words, for summarizing a distribution of data is by selecting a single number which describes how much variation and diversity is there in the distribution. Objectives. After reading this lesson, you will be able to explain measures of dispersion. You will be able to calculate the range, calculate the values of mean deviation, calculate the values of standard deviation. Now let us discuss about the importance of measuring variability. The measures of variation and diversity will help the researcher to know the complete picture of the distribution. For example, there are three friends named James, Muhammad and Ram. All three were discussing about their family average income. All three were sharing about their family's economical condition. In James' family, there are 5 people who are working and their average family income is rupees 20,000. In Muhammad's family, only 4 are working and their family's average income is also rupees 20,000. In Ram's family, only 3 people are working and their family's average income is also rupees 20,000. As all of them know that Ram's brother is earning huge salary, the 3 tried to explore more details about each family member's earning and gathered the information. In James' family, one is earning 18,000 per month, the other member is earning 19,000, the third person is earning 22,000, and the other person is earning 21,000 per month, and the fifth person is earning 20,000 per month, and the total family's income is 1 lakh rupees per month. So, if you are going to take the mean or the average of all the family members, then it is going to become 20,000 per month. And if you see in Muhammad's family, there are only 4 people who are working. One is earning around 14,000 per month, the other person is earning 22,000, third person is earning 26,000 and the fourth person is earning around 18,000 per month. And if you see the total income of Muhammad's family is 80,000. And if you are going to take the mean of the average income or the mean of the income, then it is going to become 20,000. And if you see in Ram's family, there are only 3 people who are working and the fourth person is not doing any work, that means he is earning 0 rupees per month. The second person is earning 9,000, the third person is earning 16,000 per month and the other person is earning around 55,000 per month. And the total family income is 80,000. And if you take the mean, it is also going to come to 20,000 rupees per month. From the data, we have observed although the average is same, there is a considerable difference in individuals' income. The average tells only one aspect of the distribution, that is representative size of the values. To understand it better, one has to know the spread of values also. If we observe income in James' family, the difference in income is comparatively lower. In Muhammad's family, the difference in incomes is higher, and in Ram's family, the difference is highest. Simply, average cannot provide the complete information about the given data. Sometimes, the value which describes the quantum of variation improves considerably understanding of the data. For example, the per capita income provides only average income. A measure of dispersion will provide the information regarding the income inequalities, thereby increase our understanding on the living standard of the people in the society. Measures of dispersion. Dispersion measures how various elements behave with regard to some sort of central tendency, usually the mean. The measures of the scatteredness of the mass of figures in a series about an average is called the measure of variation or dispersion according to Simpson and Kaka. There are four important methods for studying variation or dispersion. They are: first one, range; second one, interquartile deviation; third one is mean deviation; and the fourth one is standard deviation. First one, range. Range is the simplest possible measure of dispersion. It is defined as the difference between the extreme items of a series. It is represented as range is equal to L minus S, where L stands for largest value of an item and S stands for smallest value of an item. The utility of range is that it gives an idea of the variability very quickly, but the limitation is that it is greatly affected by the fluctuations of sampling. The range value is never stable and it is based on only two extreme values of the variables or data. As such, range is mostly used as a rough measure of variability and is not considered as an appropriate measure in serious studies. For example, the table provides the information regarding employee salary working in cement, iron and tiles industry, and our duty is to calculate the range for the following data. In the cement industry, there are 6 people who are working. One is earning 7,000 per month, second one is earning 8,000 per month, third person is earning 9,000, fourth person is earning 10,000, fifth person is earning 11,000 and the sixth person is earning around 12,000 per month. If you see in the iron industry, there are also 6 people who are working. The first person's salary is 4,000, second 6,000, third person is 8,000, fourth person is earning around 13,000, fifth person is earning 14,000 and the sixth person is earning 15,000 per month. And if we see in the tiles industry, the first person is earning 2,000 per month, second person is earning 5,000 per month, third person is earning around 7,000 per month, fourth person is earning around 9,000, fifth person 12,000 and sixth person is earning around 18,000 per month. In the cement industry, the lowest salary is rupees 7,000 per month and highest salary is rupees 12,000 per month. So the range in cement industry is L minus S, that is equal to 12,000 minus 7,000, which is equal to rupees 5,000 per month. So the range is 5,000 in the cement industry. If you see in the iron industry, the lowest salary is rupees 4,000 and highest salary is rupees 15,000 per month. The range in iron industry is equal to L minus S, that is 15,000 minus 4,000, which is equal to rupees 11,000 per month. So the range in the iron industry is 11,000. And if you see in the tiles industry, the lowest salary is rupees 2,000 and highest salary is rupees 18,000. The range in the iron industry is L minus S, which means 18,000 minus 2,000, which is equal to 16,000. The range in the tiles industry is 16,000. If the range is lower, that means the variation is less scattered, and if the range is higher, the variation is more scattered. Now let us discuss how to calculate the coefficient of range. Coefficient of range is equal to LV minus SV by LV plus SV, where LV is equal to largest value and SV is equal to smallest value. So let us see how to calculate the coefficient of range in the tiles industry. In the tiles industry, the highest value is 18,000 and the smallest value is 2,000. So coefficient of range is equal to LV minus SV by LV plus SV, which is equal to 18,000 minus 2,000 divided by 18,000 plus 2,000, which is equal to 16,000 divided by 20,000, which is equal to 0.8. 0.8 is the coefficient of range. Quartile deviation or interquartile deviation. The range is based on two extreme items and it fails to take account of the scattered within the range. The total distribution is divided into four quartiles. Q1, which is 25%, Q2 is 25%, Q3 25%, and fourth quartile Q4 is 25%. Interquartile deviation includes the middle 50% of the distribution, which is Q2 plus Q3, which is called as Q3. That is, one quarter of the observation at the lower end Q1 and another quarter of the observation at the upper end Q3 of the distribution are included in computing the interquartile deviation and excluding the others. It is represented using the formula interquartile range is equal to Q3 minus Q1, whereas the formula to calculate quartile deviation, which is represented by QD, is equal to Q3 minus Q1 divided by 2. Let us take an example. Find out the value of quartile deviation for the data. If we see a student has secured marks in sociology, rule number 1 has secured 56, rule number 2 has secured 65, rule number 3 has secured 36 marks, rule number 4 has secured 75, rule number 5 has secured 81, rule number 6 has secured 90, and rule number 7 has secured 43 marks. Now let us see how to calculate the quartile deviation. The first step is to arrange the marks secured by the students in ascending order. So draw a table and write the marks in the ascending order: 36, 43, 56, 65, 75, 81 and 90. And once we have written the marks in the ascending order, the second step is to calculate Q1 value. Q1 is equal to size of n plus 1 divided by 4. The item which we are going to get, that is going to be the Q1 value. Here n is equal to 7 because there are 7 students. So n is equal to 7. So Q1 is equal to 7 plus 1 divided by 4, which is equal to 8 by 4. We are going to get second. So the second item will be the Q1 value. So Q1 is equal to 43. And the third step is to calculate Q3 value. Q3 is size of 3 in bracket n plus 1 divided by 4. Here also n is equal to 7. So 3 into 7 plus 1 divided by 4, which is equal to 3 into 2, that is nothing but sixth item. So if we see in the series, the sixth item is 81. So now we got both Q1 value as well as Q3 value. So in order to calculate the interquartile range, the formula is Q3 minus Q1, which is equal to 81 minus 43, which is equal to 38. So in order to calculate quartile deviation, the formula is QD is equal to Q3 minus Q1 divided by 2. So that is equal to 81 minus 43 divided by 2, that is 38 divided by 2, that is equal to 19. So the quartile deviation of the scores is 19. And let us calculate the coefficient of range. It is defined by Q3 minus Q1 divided by Q3 plus Q1. So Q3 minus Q1, that is 81 minus 43 divided by 81 plus 43, that is equal to 38 divided by 124, which is equal to 0.31. That is the coefficient of range of the scores of the students secured in sociology. Let us take one more example to have a clear understanding on how to calculate the quartile deviation. If we see the income of respondents, the person who is earning around 20,000 per month, there are 16 people. There are 22 people who are earning around 25,000 per month. There are 31 people who are earning around 30,000 per month. There are 18 people earning around 35,000, 19 people 40,000, 51 people they are earning around 45,000 per month, and there are 7 people who earn around 50,000 per month. Our duty is to calculate the quartile deviation for this series. Solution. Once you have the table, the first step is to draw the table and calculate the cumulative frequency. In the first row, you keep the serial numbers. In the second row, you put the income of the individuals. In the third row, you write the frequency, that is nothing but the number of people whose earning is 20, 25,000 and so on. So, our duty is to calculate the cumulative frequency. So, in the first one it is 16, so we are going to simply keep 16. In the second column, 16 plus 22, which is equal to 38. 38 plus 31 is equal to 69. 69 plus 18 is equal to 87. 87 plus 19 is equal to 106. 106 plus 51 is equal to 157, and 157 plus 7 is equal to 164. So, we have calculated the cumulative frequency. And the next step is to calculate the Q1 value. Q1 is equal to size of n plus 1 by 4. N is equal to 164. So, Q1 is equal to 164 plus 1 divided by 4, which is equal to 41.25. 41.25 is greater than 38. That is the reason why it comes in the third column. So, Q1 is equal to 30,000 per month. Then the third step is to calculate Q3 value. Q3 is equal to size of 3 into n plus 1 divided by 4, which is equal to 3 into 164 plus 1 divided by 4, which is equal to 3 into 41.25 is equal to 123.75. So, this comes in the sixth one because it is greater than 106 and less than 157. So, we are going to select the sixth one. So, the Q3 value is 45. So, now our duty is to calculate the quartile deviation. The formula to calculate the quartile deviation is QD is equal to Q3 minus Q1 divided by 2, that is equal to 45 minus 30 divided by 2, that is equal to 15 divided by 2, which is equal to 7.5. So, the quartile deviation is 7.5. Let us calculate the coefficient of range. Q3 minus Q1 divided by Q3 plus Q1, which is equal to 15 divided by 75, which is equal to 0.2. So, that is 0.2 is the coefficient of range. Now, let us take one more example to calculate the quartile deviation for the continuous series. If we see the income group, the income of the individual is between 0 to 5,000 rupees. There are 12 people who are earning that. There are 15 people whose earning is around 5,000 to 10,000 rupees. There are 16 people whose earning is between 10,000 to 15,000. 29 people are earning around 15,000 to 20,000. 45 people are earning between 20,000 to 25,000. 16 people are earning around 25,000 to 30,000. 32 people are earning around 30 to 35,000, and 36 people are earning between 35,000 to 40,000. So, this is the continuous series, and our duty is to calculate the quartile deviation of the scores. The first step is to calculate the cumulative frequency. So, in the first one we are going to get 12 because there is only 12. In the second column, 12 plus 15, that comes to 27. 27 plus 16, it comes to 43. 43 plus 29, it comes to 72. 72 plus 45, it comes to 117. 117 plus 16, it comes to 133. 133 plus 32, it comes to 165. 165 plus 36, it comes to 201. The second step is to calculate Q1 value. Q1 is equal to size of n plus 1. So, n is equal to 201. Q1 is equal to 201 plus 1 divided by 4, which is equal to 50.5. So it comes in the fourth number because it is greater than 43 and it is less than 72. Q1 lies in the income group of 15,000 to 20,000 per month. The formula to calculate Q1 is equal to L plus N by 4 minus C divided by F, where L stands for lower limit of the model group, which is 15, N is equal to number of items, which is equal to 201, C is equal to cumulative frequency prior to the model group, which is 43, and F is nothing but frequency of the model group, which is 29, and I stands for interval, that is 5. Q1 is equal to L plus N divided by 4 minus C divided by F into I, which is equal to 15 plus 201 divided by 4 minus 43 divided by 29 into 5, which is equal to 15 plus 50.25 minus 43 divided by 29 into 5, which is equal to 15 plus 7.25 divided by 29 into 5, which is equal to 15 minus 0.25 into 5, which is equal to 15 minus 1.25, which is equal to 13.75. So we have calculated Q1 value, which is 13.75. The third step is to calculate Q3 value. Q3 is equal to size of 3 into n plus 1 divided by 4, which is equal to 3 into 201 plus 1 divided by 4, which is equal to 3 into 50.5, which is equal to 151.5. So 151.5 item lies in the income group of 30 to 35. The formula to calculate Q3 is equal to L plus bracket open 3n divided by 4 minus C by frequency into I, where L is equal to lower limit of the model group, which is 30, N is equal to number of items, which is 201, C is equal to cumulative frequency prior to the model group, which is 133, and F is frequency of the model group, which is 32, and I stands for interval, which is 5. Now we have to replicate these numbers in the formula. Q3 is equal to L plus 3n divided by 4 minus C divided by F into I. 30 plus 3 into 201 divided by 4 minus 133 divided by 32 into 5, which is equal to 30 plus 150.75 minus 133 divided by 32 into 5, which is equal to 30 plus 17.75 divided by 32 into 5. 30 minus 0.55 into 5 is equal to 30 minus 2.75, which is equal to 27.25. Now we got Q1 values and we also calculated Q3 value. Now our duty is to calculate quartile deviation. The formula to calculate quartile deviation is QD is equal to Q3 minus Q1 divided by 2. QD is equal to 27.25 minus 13.75 divided by 2, which is equal to 13.5 divided by 2, which is equal to 6.75. The quartile deviation is 6.75. Now let us calculate the coefficient of range. Q3 minus Q1 divided by Q3 plus Q1, where Q3 is equal to 27.25 and Q1 is equal to 13.75. So by replicating these values in the formula, we are going to get 13.5 divided by 41, which is equal to 0.33. Mean deviation. Mean deviation is the average of differences of the values of items from some average of the series. The difference is technically derived as deviation. In calculating the mean deviation, we ignore the minus sign of the deviance while taking the total for obtaining the mean deviation. The formula for calculating mean deviation is omega of mean is equal to sigma of xi minus h bar, which is h bar is nothing but the mean divided by n. By using this formula, we are going to calculate the mean deviation. Mean deviation can also be represented by MD. Example 1. A student took 5 exams in UG first year and he has secured 92 marks, 75 marks, 95 marks, 90 marks and 98 marks in 5 subjects. And our duty is to calculate the mean deviation of this test scores. So, let us see how to calculate it. The first step is to calculate the mean value for the given scores. Mean is equal to sigma of xi divided by n, which is equal to 92 plus 75 plus 95 plus 90 plus 98 divided by 5, which is equal to 450 divided by 5, which is equal to 90. The mean is 90. The second step is to draw table. In the first row, write all the scores 92, 75, 95, 90 and 98. In the second row, subtract these numbers from the mean, that is 92 minus 90, which comes to 2, 75 minus 90, which comes to minus 15, 95 minus 90, which is equal to 5, 90 minus 90, which is equal to 0, 98 minus 90, which is equal to 8. So, now we have made the subtractions and we have written the values. Now, the third step is to calculate the total of the differences. So, 2 plus 15 plus 5 plus 8, which is equal to 30. Now, we have calculated the total of the differences, that is sigma of xi minus x bar is equal to 30. Mean deviation MD is equal to sigma of xi minus x bar divided by n, which is equal to 30 divided by 5, which is equal to 6. So, the mean deviation of the score is 6. So, we can say that on the average, the student's test scores deviated by 6 points from the mean. The coefficient of mean deviation is calculated by formula MD divided by M. MD is equal to 6 divided by mean, M is mean, 6 divided by 90, which is equal to 0.07. Standard deviation. Standard deviation is widely used measure of dispersion of a series and is commonly denoted by omega. Standard deviation is the measure of the dispersion of a set of data from its mean. The more spread apart the data, the higher the deviation. Standard deviation is calculated as the square root of the average of scores of deviations. Omega is equal to sigma in bracket xi minus x bar whole square under root divided by n. For example, a psychiatrist wished to measure the IQ levels of the children aged 11 years. The IQ levels of the children are 80, 65, 70, 85 and 75. Our duty is to calculate the standard deviation. The first step is to find the mean of the scores. X bar is equal to sigma xi by n, which is equal to 80 plus 65 plus 70 plus 85 plus 75 divided by 5, which is equal to 375 divided by 5, which is equal to 75. The mean scores of the IQ levels of the children is 75. The second step is to draw table. In the first row, write all the scores. In the second row, subtract the mean value from the scores and write the results. X minus x bar. X is 80 and x bar is nothing but the mean, which is 75. 80 minus 75 is equal to 5. 75 minus 75 is equal to 0. 65 minus 75 is equal to minus 10. 70 minus 75 is equal to minus 5. 85 minus 75 is equal to 10. The third step is to calculate the squares of the differences and add them. So here we have the difference is 5. 5 square is nothing but 5 into 5 is 25. 0 square is 0. 10 square is 100. 5 square is 25 and 10 square is 100. So now we are going to add all these squares of the differences. 25 plus 0 plus 100 plus 25 plus 100, which is equal to 250. Now we got the values, that is sigma of xi minus x bar whole square, which is equal to 250. And our duty is to simply put these values in the formula. Delta is equal to sigma of xi minus x whole square under root divided by n, which is equal to 250 under root divided by 5, which is equal to 3.16. The standard deviation is 3.16. Now let us sum up. Measures of dispersion provide a way to analyze and map data and infer conclusions. You have learned about measures of dispersion, that is range, mean deviation, standard deviation and quartile deviation. These tools will help us to understand the variation between the variables.